Hello and welcome back to College Algebra, MAT 150. In this lecture we will be discussing factoring basic trinomials. So what is a trinomial? Well, it's something with three terms. So how do we do this and what do we mean by basic? Well, in this case we're referring to the what's going on with the x squared term. So we don't want there to be any number in front of the x squared. So basically x squared plus bx plus c, where b and c can be any numbers. So how do we do this? Well, the basics are we're going to look for two numbers that multiply to be c. So the h, we're calling them h and k, that also add to be b. So if we find those two numbers, we then can separate, since they h and k add to be b, then b of x can be separated into h of x plus k of x. So then what do we have? We'll have 1, 2, 3, 4 terms. Instead of a 3-term thing, we'll have 4 terms. And when we have 4 terms, just like as we did in the previous video, we can use factor by grouping. So what are we going to do? So factor the following trinomials. So again, we're looking for two numbers that multiply to be the c part. So in this case, we got x squared plus 12x plus 20. The c is the 20. So that's what we're always going to start with. So we're always going to look at the number and look for two numbers that multiply to be 20. Now, this is a pretty exhaustive list. So sometimes if you're lost, you can just start with 1. So 1 and this number, whatever that number is. If it's include the negative, so if it was negative 20, you'd put negative 20 there. So we include the whole c. So 1 times 20, but then we also have negative 1 and negative 20, because a negative times a negative is a positive, right? You can go through and make an exhaustive list like this. So another two numbers, so you start with 1, we go up to 2. 2 and 10, and include the negative version of it. What's the next number? Well, after 2. Well, 3, but 3 doesn't divide into 20. 4 does, though. And we have 4 times 5, and then negative 4 times negative 5. What happens if we keep ascending on the positive one more? Well, we'd have 5, and the only thing that multiplies by 5 to get 20 is 4. We've already talked about that. So this is an exhaustive list of all integers, pairs of integers, that multiply to be 20. So do any of these also add to be 12? Well, the 2 and the 10 do. So to be clear, always start first with the multiplication parts. Then ask two things that multiply to be 20, then see if any of them add to be the middle b, the b coefficient. And if they do, you can continue. So we have x squared plus 12x plus 20. And this means that this 12x can then be broken into x squared plus 2x plus 10x plus 20. Is this exactly the same thing as this? Yes, because 10x plus 2x is 12x. But why did we do this way? So that we can now do factor by grouping. So I have x squared plus 2x. We're going to call that one term. What's always between the groups? We put a plus. And then we have the next term. So the next two terms, 10x plus 20. And then we have x squared plus 2x. What is a common factor? Well, x is. Then we can pull out, so we pull out the x and we're left with x plus 2. And then we have 10x plus 20. What's a common factor? Or the GCF, it's 10. We divide by 10, so 10x divided by 10 is x. 20 divided by 10 is 2. And now, just to kind of keep this separate, I'm going to put this line right here. We have two binomials, or two terms. And there's a common binomial in each of those terms of x plus 2. And then we have x plus 10 left over. So x and the plus 10 left over when we get done. So we have just factored our first trinomial. All right. So what about this next one? Well, we start the same way. we look at the negative 54 part first. So again, include the negative if it's there. And again, you can make it a very exhaustive list. 1, negative 54. And there we then included both negative. Here we're just going to change the signs. Negative 1 and positive 54. Well, does negative 1 plus 54 add up to 3? No, it's positive 53, which is way off from what we need. So we just go up the line, 2 and negative 27. Again, that difference is too big, so is the reverse of that. So 1 minus 54 is negative 53. Negative 1 plus 54 is positive 53. So the pairs will always be plus or minus. When you add them together, will be the positive or negative of each other. Okay? So we don't need to then check negative 2, 27, because 2 minus 27 is negative 25. So if we did negative 2 plus 27, that would be positive 25. So again, you only need to check one to see if it's in the ballpark. So then we move on. After 2, we have 3. So we have 3, and let's see here. 54, so bring the 3 here, so that'd be 9, 18. So negative 18. So 3 times negative 18 is negative 54. 3 minus 18 is negative 15, which is not what we need. So again, we march on. 54 is not divisible by 4. 54 is not divisible by 5, but 54 is divisible by 6. And if we do 6, so I bring out the 3 and negative 9, well, 6 minus 9 is in fact negative 3 if we added them together. So this is the pair that we're looking for. Then, since we found it, we don't need to continue on. You could try if you wanted to, but as it turns out, negative 6 and positive 9 would be the only other factor pair that you could have that you continue to be bigger. But we have this, and we have x squared minus 3x minus 54. We're going to split the middle term. It's going to be split into 6x minus 9x. So we just rewrite this. X squared minus 6x plus 9x minus 54. Then we have 1, 2, 3, 4 terms. Or excuse me, I'm so sorry. Positive 6x minus 9. So x squared plus 6x minus 9x minus 54. And that's 4 terms. And then we have x squared. We'll start grouping them. X squared plus 6x is one group. What's always between groups? A plus. That means this negative 9x is going to be grouped here. And then, what can we factor out of x squared plus 6x? Well, we can factor out an x. That reduces this by 1, and that x goes away, so x plus 6. What can we factor out of negative 9x minus 54? Factor out a negative 9, so that we're just left with x, and negative 54 divided by negative 9 is positive 6. This term and this term both have a common x plus 6, and then we have an x and a minus 9 left over. Now, this is a good time to note this. I've shown you this full method. Some of you may realize this is a bit much. But because notice, when we factor this, what did the factor become? So for this first one, x plus 2 times x plus 10 is what this factored up to be. What's interesting about the 2 and the 10? Well, those were the same two numbers that multiplied to be 20 and added to be 12. And then if you notice over here, this is an x plus 6 and an x minus 9. X 6 and negative 9 were the two numbers that added to be negative 3, that multiplied to be negative 54. This is no coincidence. You can skip, once you have these numbers, you can skip straight to here. That is possible. You can bypass literally all of these steps. But, and to be clear, this is useful if there is a number in front of the x squared term. Okay, so this method won't go away, what we just did, so it's not all for naught. You now have a shortcut available to you, but that's only if it's just x squared. In the very next lecture, we will talk about what you do with there's a number. So it's still useful, okay? But to sort of beat this home, we'll have a sort of extra example. Let's do x squared plus 5x plus 6. What are two numbers that multiply to be 6 and add to be 5? 2 and 3. And again, once you know those two numbers, you can just go straight to this. But again, this shortcut does not work if you have an a. So it doesn't work for a's not equal to 1. For ax squared plus bx plus c plus for these trinomials. So basically, if you have a number here other than 1, this trick doesn't work. But if it is 1, that's a very nice trick to have. So back to the last example, the next example, we see x squared plus 7x plus 16. So we ask the same question. What are two numbers that multiply to be 16 that add to be 7? And maybe we can use our trick if that's the case, instead of going through all that. Well, 1 times 16 is not 7. Same thing, negative 1, negative 16. Because because when you deal with a positive, both of them are positive or both of them are negative. If they're both negative and this is not negative, then you don't need to worry about that. Similarly, if it's negative, you don't need to worry about the positives. So 2 and 8. Well, 2 times 8 is 16, but 2 plus 8 is 10, so that's not it. So let's try again. 3, well, 16 is not divisible by 3, so the next number is 4. Well, 4 and 4 multiply to be 16, but they add to be 8. That's just shy of where we need to be. But if we make 4 bigger, like 5, 6, 5 isn't divisible, 6 isn't divisible, 7 isn't divisible, but 8, well, if we did 8, we've already done 2 and 8. So we just have 8 here, but 2 on the other side. So we've exhausted all of our possibilities, and none of them added to be 7. If that's the case, and nothing works, we say that we can't factor this. It's either you can say unfactorable or you can say prime. So I'm just going to say prime. Prime in the similar sense of what you talk about with a prime number. All right. That concludes this lecture.